Okay, thank you all for coming and good morning. I hope you had a great time yesterday. I was in my room making these slides. Um, Today we're going to talk about some experimentation I've been doing, playing around with different dependency managers in C++. No. If you don't like looking at a lot of CMake files, the door is over there. So just so you know. And I won't be offended if like your CMake overload is like, and then you just leave. It's fine. It's 9 o'clock, so it's all right. So my name is Patricia also. I'm a trainer and a consultant. We did a training just before NDC, teaching foundational C++, which was a lot of fun. I'm a C++ programmer. I've been doing it for 16 years now. I work at a company that I co-founded called Turtlesec. I've worked on a couple of browsers. I worked at Cisco making embedded telepresence systems, and I've even been a Java consultant for 2 years, I think. I have a master's degree in computer science, and my pronouns are she, her. Okay, so which ones are we looking at? Because this is going to be very code-oriented, as opposed to most of my talks. So we're going to look at Conan, CPM, which I think is supposed to stand for CMake Package Manager, Fetch Content, and VC Package. There are also some unfinished examples in my repo, which is all of this is based on. If you have your favorite package manager that you think can do what I'm trying to do in this presentation, just give me a pull request. So why should you have dependency management? Sometimes you end up having a dependency that turns out to be making you vulnerable in some way. It turns out to be a huge vulnerability for your system, even though it wasn't your code. And this is an overused example of this, but it was massive, and it is a problem that hit the entire industry and also made us make foundational changes in how we deliver software to end users. Heartbleed was a vulnerability in Openssl that allowed a remote process, a remote machine, to dump the memory of a process that had that was running Openssl, that had it loaded. You could dump the entire virtual address space of that process, which then often included all of your private keys, all sorts of things. You could do this totally stealthily. It was very easy. You basically just had to send the right bytes, and you were off running. So it was pretty terrible, especially because Heartbleed was loaded into processes and machines all over the world, and some of them had never been updated, or at least not for many years. Some of them weren't possible to upgrade because they weren't designed for it. So it became a massive problem for the entire industry. But this is just one like super famous example. The thing is that if you want to find vulnerabilities and get your money back, finding vulnerabilities can be hard. Finding ways to exploit them can be hard. All of this is time consuming and therefore costs money. So if you can find something in a commonly used application or commonly used library, then you can apply it against many targets. So hitting libraries is very attractive, especially popular libraries. And by virtue of being popular libraries, it means a lot of people are using them, right? And that might be you. So, do you know today, for example, which version of Openssl is running in all of your products? And then I mean all versions of your products that your customers are currently running in production. Could you update it if needed? Like if you found out today, oh my God, there's a huge vulnerability in it. Do you know how you could do that? And what about all of the ones that are already deployed? What if it's a transitive dependencies? You haven't actually written it up anywhere. It just kind of gets pulled into your build. Maybe you have multiple versions of it. So you think you have one, but actually you have like 4 different versions, and one of them is vulnerable. The problem is we don't necessarily have the knowledge of what is running in our systems because we don't necessarily track it. Now, that's not true for everyone. Like, some companies are really good at tracking this, other companies are not, and there's a lot of span in between. So what we want is some sort of order, right? And that's not necessarily very simple to do. You can say that in JavaScript I have specified that these are my dependencies, but then you go and you look in your node modules folder and you basically downloaded the internet, right? So just because you have a list of dependencies doesn't necessarily mean that you know what you're running. So we could go old school, and we'll just copy paste the code. So we'll copy paste the dependency into our code, and it's mine now. I don't have to worry about them breaking my application because I copied it, so it's fine. Unfortunately, now, if there are any vulnerabilities discovered in this dependency, now they're my vulnerabilities, and I might not be paying attention. So then I have to be on top of all kinds of security patches on my upstream for all of the things that I have copied. And how am I going to do my upgrades? Like, what if I just have been patching and patching and patching for a long time? So now I have like 50 patches on this dependency, and now I have to upgrade it. How am I going to do that? Okay, so in this presentation, we're going to look at a demo project. And then I'm going to try to use the dependency managers I mentioned to try to get the dependencies for this. And we're going to look a little bit on how it integrates in CMake and how interchangeable they could be. So I have some requirements for the dependency manager that I'm going to use. First of all, I wanted to work with CMake because this is a CMake project, and so I want my dependencies, and I wanted to work with CMake. I want it to be easily replaced, easily in quotation marks. It doesn't have to be super easy, but it comes down basically a lot to, does it have my key dependencies? And that's not necessarily the case, and depending on how much work I want to do, I'm not necessarily ready to integrate my dependency with the system. I want to be able to invoke it from CMake. Now this is a whole like religious thing where people will argue loudly. The thing is, I often work with students and things like that, and I want them to just be able to open the project and have it just work. I don't want them to have to run tons of scripts and synchronize their whatever. I want them to be able to go to the project, open it in CLion or Visual Studio or Qt Creator or whatever, and it should just work. Quotation marks. I also want something that is maintained because I actually want recent versions of my dependencies. And I also want bug fixes. So if nothing happens and there's an open bug for a long time, that's going to make me skeptical. One of the things that I realized talking about this is there's like a fuzzy kind of line between what we consider to be, and this is especially on Linux, like what we consider to be package management and what we consider to be dependency management. And that's because on Linux, you can basically get a lot of your dependencies through your package manager, but that isn't necessarily what you're looking for here. And so trying to figure out where is the natural line between package management and dependency management is not something I managed to do. Like I feel like there is a line, but I'm not exactly sure where it is. I feel like, like your X libraries might be on one side of the line and then Qt might be on the other side of the line, but exactly where that line goes, I don't know. So maybe it goes around something that somebody mentioned to me on Twitter. Maybe it's around like the idea of a system SDK, because on Windows or Mac you can kind of like install a system SDK, and this is how you do like programming against the system. Also thinking about like what is reasonable for you to build from source. Like what is it that you don't necessarily need to build from source, or you can just use as installed libraries. And what is that line? Maybe the line between package management and dependency management is like some kind of fuzzy line of a system SDK. And maybe the line is between like what you need to build and what you what you need runtime, what you need to ship. So the code that we're going to look at is like very small, but it had certain requirements. So it had to be a non-trivial example, and that's mostly in functionality. It should have, because I wanted non-trivial dependencies. I also needed to compile. So the features of the application that I'm going to use is that it basically renders a window using SFML. And if I misspell that, I do that all the time, so sorry about that. It logs to the console using FMT, and then it has a test using catch2, which basically asserts true. So this is a very interesting project. And the basic project structure is I have some project and then a source folder where I have a CMake file, a main, a test folder with like a test file, and then like a root CMake. So this is like the most silly program you've ever seen. Okay. So first, let's see if I can show you what it looks like. So this is, okay, since we're going to do Conan first, let's do Conan first. So basically, this is it. It's super not interesting. Let's see. So if you see here, it opens a window. I haven't put anything in the window. It says hello Conan on top, and it prints hello Conan down here. That's all it does. Nothing interesting. Okay, so let's look at the main. The main is basically a modified example of like a hello world for SFML. Most important thing is, so here we're using format, we're printing, we're using format, and then here we are including an SFML header, and then we are making a window. So not very interesting, but it means that I actually need these things to be found and installed and in my path, and you know, all of these things for this to compile and work. So yeah. So then let's look at the test code, which is like even better. Again, the whole idea is that I just have to find catch. Yeah, so let's look at the root CMake. So this is the basic skeleton of my root CMake. It doesn't really have much. It says, you know, that I have some project. I require C++17, which will be an issue in a little bit. And then I have my subdirectories. Yeah, so the dependencies is SFML version 2.5.1, catch2 2.13.7, and then format 8.0.1. And these were picked basically because they were newest ones I found on GitHub, so for no other reason. Okay, because that was one of the things I wanted to see if I can get the latest version that I found on GitHub. And that will also be something we will talk a little bit about more later. So the source CMake file is very simple. This is the goal. Like this is what I would like it to do. Like this is like CMakey. So it's not like I don't think I have any highlights. Oh yeah, I do have some. So I want to be able to do like find package for stuff, and then I just want to use this kind of notation. That's not necessarily something I'll be able to manage, but you know, that feels like the right way to go. So let's look at the CMake for the test. So here is again, I would like to use find package for catch2. And the reason why I want to use find package is that that comes back to the requirement that I would like it to be relatively easy to change things out. So it would be relatively easy to use a different dependency manager. And so I would like the rest of the CMake to be the same. It would be nice if I don't have to change the CMake, even if I play around with dependency managers. I also have like a GitHub action workflow for all of this, which since I I nerd around it a lot, then I included it here. So this is the basic structure of it. So one of the things that I didn't write on a slide, but you can tell from here, is that I wanted to work on Linux, Mac, and Windows. So I want the same code to work on all three platforms. I want it to work magically on all three platforms. And so here I do my CMake step, then I do my build step, and then I run my tests. So I basically want pretty much the same code for all three of or all four of my my dependency managers. I don't want to make too many changes. I will make some changes and I will point them out for each one of them, and it's mostly around caching because I want to cache my dependencies in my GitHub action so the builds take shorter time. Okay. Yeah. So this the project is called Depend on Me. It's on my GitHub. So the first project I have there is Conan, and then CPM, fetch content, and the VC package. And then there's a root CMake. And so we're not going to go into the root CMake, but I use this like an external project for pulling everything together. So let's look at Conan. I don't have a lot of like meta stuff like, oh, I will tell you about Conan. So most of my notes here are like just my notes while I'm doing. So one of the good features about Conan is it does have a lot of dependencies. It might be my like feelings, but I feel like it used to have more when we had like bin tray and stuff. But the nice thing about now is like it has a repository with all of the recipes for building a lot of dependencies. They are well tested. They are maintained. They're often at the most recent version. So as a quality mark, I think it's pretty good. It does support a lot of configuration, and I think maybe that's what I like the most about it, that I can tweak it however I'd like. And I tend to do that for my most critical dependencies. Yeah, and it's actively supported, so I like that. It also has, yeah, like I said, recent versions of things. So if we look at the root CMake, it's pretty much the same as before. So I gray out like if it fits into the pattern. So what I'm going to do here is that I'm going to use this technique where I just put the setup of whatever package manager I have into like its own CMake file. So that's what I do here. Okay, so the first thing that I do up here is I set sys requires mode to enabled. And this means that Conan is allowed to install system packages. This only happens on Linux. But there are some system packages that are required, and that is true for all of the dependency managers. But for the other ones, I have to install them myself. So yeah, so then I download the CMake file from Conan, and this is the same structure that we have for a few of these, that they just have a CMake file that you can use, and then I include it, and then I just call like CMakey functions. Yeah. So the Conan file, like how I specify so there are two ways to do Conan stuff that I know of, at least. Many ways actually. You can also write it in the CMake, but I don't care about that. But this is the simplest one. So this is just like a text file. And there's also a Python script that you can write. I often use the Python script in other projects, but I feel like this is easier. So if you can use this for like student projects, it's better. So basically, I list my dependencies and their versions, and since I don't do anything else, it's going to go look at Conan index to try to find them. And then I can also set some options. And then there's a bunch of generators for making everything play nice with CMake. And apparently they are going to become deprecated, and there's apparently some other new ways of doing things. But not with my current version of Conan. So the CMake list, for the source, this is basically exactly the same as how I wanted it to be, right? So I'm like super happy with this. I didn't have to do anything. It looks exactly like I'd like it to look like, so I'm happy with that. For caching, there's some small issues. Now here, I also set this in the GitHub action because I did that first. You could probably remove that. But one of the nice things that I like is that I can set up these environment variables to say where the Conan cache should be. That might exist for the other ones, but I don't know about it. One of the bad things is that, and I've done this mistake before, is that I can end up having Conan problems if I don't do this Conan remove sysrex because of my cache. Apparently, my cache and Conan, my GitHub cache. So the middle part here is the GitHub action cache. Which I really recommend people use if they're using like any kind of dependency manager or any kind of thing that takes a long time to calculate and you just want to reuse in a later thing. It's very simple and it doesn't always work, but it works most of the time. So you basically just create the cache, you tell them what it's called, then you basically just give the path. Oh God, go walk away from the speaker. You give the path that you wanted to cache, and it basically just zips it up and uploads it to some kind of GitHub server. And next time it will go and it'll check if it has a cache with this key, and if it does, it will just unzip it in that location. So how you make sure to how you can invalidate your cache is by making sure that the key doesn't match. So a normal way to do that is just to have a hash of some file that invalidates it. It can matter or not. It doesn't. It's Just make sure that the cache is different for your different platforms, so it's gonna be weird, I guess. Okay, so CPM. So CPM is basically just fancy syntax on top of fetch content, and we'll get back to fetch content. So basically, I'm not sure I consider this like a real dependency manager. It's just a way of getting code from GitHub, basically. Get code from GitHub and build it locally on your machine. But it is a lot of people use it, and it's probably better than copying the code from GitHub. So what I don't like about this one and with fetch content is that I can't use find package. So another thing that I didn't like here is that, and there's probably a way to get around this, but I had to build with C++ 14 because SFML uses std auto pointer, and I couldn't set I needed a way to say for SFML I would like to build with C++ 14, but everything else C++ 17, and no, was not happy. Okay, so the basic structure is the same as with Conan, kind of. It's like I just download the CMake file, and then I include it. The other thing here is that there's not a separate file for specifying the dependencies, and I'd actually like it if it was a separate file. Then I could also use it to hash and stuff. So that would be good for my caching and stuff. And also it would make it clearer when you're changing your dependencies versus when you're messing with how to deal with your dependency manager. I'd also, and that's another thing I probably get to later also as well, is that I would really appreciate some kind of standard on how to specify my dependencies, because they're all semi-different. The syntax here is kind of it's the GH is GitHub, of course. So basically it says download download catch format and SFML from GitHub, and these are the versions. And then I had to use the hash thing because it assumes that all version tags starts with a V. So if you don't have, it works, but I'm not it's not my favorite thing in the world. And the other thing that I didn't like is that I can't use find package. So some people might say that, this is, but this is shorter. But the thing is now I have to, if I am going to switch to something where I require a find package, now I have to go and find everywhere that I need to put in a find package, so it just makes things harder. Yeah, caching is like super simple. But now I have to use as a hash file like CMake lists or something. Like it's just, I'm not like super happy. Yeah. Okay. So next one, fetch content. So I've already mentioned fetch content. So this is basically a CMake, just a CMake script comes straight out of. You can use it for whatever you like. It's really super useful for certain things, and I will use it with VC package actually. But again, I can't use find package, and I'm not a fan. It's also, the thing is, the problem with both like CPM and fetch content is basically they just like get code from GitHub and build it however they build. So there's now, I don't have any real control over my dependency graph. I don't know, now I'm worried I might have different versions of different libraries, and I'm like, I am not super happy, but it's super easy to use. And again, I have to use C++14, so not happy about that. But it's super simple to specify stuff, like, so you just include fetch content that comes with CMake, so you just like, and then you say, go get stuff from GitHub, and then make it available for me. Maybe there are better ways of doing this, which meant that I could use find package, but I don't know about them, so you should tell me. And again, then we're missing the find package. We're missing the SFML like prefix here. Not super happy about that. Easy to cache, like same thing as before. VC package. So I hadn't used VC package a lot until like this year. But I kind of like it. One of the things that I kind of like, it sounds kind of weird, but I like it because Microsoft does it. Mostly because I feel like the people who are doing it are getting paid, so there's a higher chance I'm like they'll not burn out, and but I do use fetch content to actually get VC package, which is interesting. One of the things I don't like is that I'm not specifying version. I think there's a new feature in VC package. Anybody here from VC package where I can specify version? Yes. Is it out? Yes. Okay. Yeah. So yeah, because I've heard that there's like a way to specify it. Like how it used to work, or my mental model of it at least, and how I'm using it is sort of like, is like a repo where you just kind of check out a tag, and all of the dependencies are at whatever version. Not like a super fan. Like I don't really like that. I like to have better control, but so then we have the VC package thing. It basically uses fetch content and one of the, some of the more like advanced features of fetch content to get stuff. And then you can specify a toolchain file. Another thing that you can do that I don't specify here is that you can pass in your own toolchain file, which is really cool. Okay, so they use a JSON format. So this is the one that I'm currently using. If somebody wants to upgrade me to new like version-y syntax, please do. Okay, so this is the source CMake. I'm not super happy about this because I have to add in some find package stuff for Linux only to make sure that it works. So yeah, not super happy about that. Otherwise, I'm also like, yeah. My entire talk is going to be about me just saying I'm not super happy about that. Sorry about that. Okay, so and then the caching is great, right? So there's some stuff that I have gotten pull requests on that aren't finished because they don't fulfill the requirements. So the requirements is they have to be able to be called from the CMake, and they have to work on all 3 platforms, and stuff like that. So I got a pull request for using Conda, and Conda seems kind of cool. I'd never heard of it before, but it's sort of like a package manager, but it's like cross-platform package manager. but it was basically very much like you have to set up like it has to be done from the command line kind of thing, and it isn't like super easy to install, and yeah. So, but I might be able to integrate it in the future. I got some ideas on how that could be done. Also got a pull request for using external project, which is also a CMake feature. And external project is super cool, and apparently somebody told me that like LLVM uses external project a lot. But basically, it just means that you can just like take, let's say that you have a third-party project that you're pulling in as a Git submodule or something. Then you could, and it like has all of its build files and whatever. Then you can embed it into your CMake structure by just saying this is like this external project, which is in the subfolder, build it and make it available to me. Which means that you don't have to make any changes to it, and it's a really like a nice way of handling, like, especially I use this in an embedded project for like having a root project with different like different chips that have different tool chains, because CMake doesn't really support like having different tool chains. But with the external project, I can have different tool chains for each sub project, so I can still have them all together. So it's it's a little bit of like a big hammer, but sometimes a big hammer is kind of nice. There's also like the beginnings of a hunter, which basically means it's like almost an empty folder. So it's just because I Googled a lot. I didn't find good examples, but I'm sure there are one. I think there probably are more, and very often like the dependency managers are tightly like coupled with the build system, and in this case I just want the dependency manager, and I want to see if I can do that. Somebody even told me that I could use Gradle for C++ dependencies. Not sure how that would work, but apparently some people are doing that. So this brings us to the problem. Like it's like I'm spending all of this time trying to specify my dependencies, but I'm only specifying my top level dependencies, and these have like transitive dependencies, a lot of transitive dependencies, and so I need more. I need more than inking on a number, right? I need some way to see the dependency graph. I need some way to audit my dependency graph. If I made like proprietary software, I probably needed some way to audit all of the licenses of all of this stuff. I need more. And I think it's like, this is a good step, but it's still not enough. I need more. And the thing is like we might know like the foundational level of our dependencies, the top like surface of our dependencies, but what about everything else, and duplication and transitive dependencies? Do I know the versions of it? Is there a way for me to track it? Can I make system to track it? Can I make a system to audit them? Do I even know if the versions of my dependencies have known vulnerabilities, and how can I tell? Like, can I have some way of monitoring that like automatically? And there are some proprietary systems for doing some of these things. And I've been also chatting with SNCC, and SNCC they're also working on C++ stuff. That could probably, like, some of it could be used for open source projects for free, but they're not finished. And the one thing that I get back when I talk to people who are making vulnerability scanning stuff for dependencies in C++ is that they come back to me and they say, but Patricia, it's like nobody's using dependency managers. It's like what they're doing is they just have all of their dependencies in some kind of file system. And they have patches on them, and they are like unknown versions of them. And it's like, we've been going to customer after customer, and nobody actually has a well-structured system for this. So they say that the only thing that works is basically to go and do hash matching of files and fuzzy matching of files to try to guess, first of all, which library is this, And and which version of that library is this? And the thing is, I feel like that is like the most silly problem to have. Like, at least the minimal thing we should know is which library is this and which version of that library is this, especially if it is on disk. Like, if you're coming to a point where you have a file system and they're all checked out in there and you can run like a tool on that file system, why is that tool guessing what your libraries are? And the thing is, it doesn't get, like, even the proprietary tools I've talked to, like, even they don't guess well. Like, so you're running some tool that you're spending like thousands of dollars on, or hundreds, I don't know how much these things cost, and it has like a guessing percentage of like 80%, guessing correctly which library it is. And I'm like, why am I paying all that money to tell me what's in a folder on my disk? So and the other thing is that I noticed that a problem that people have: can you rebuild everything that you support? Like, anything that you shipped, can you build it again? And that doesn't go for anything you ship today. I'm not worried about what you ship today. What about those things you shipped 5 years ago that you are still supporting? Can you build those? What if you have a vulnerability in software that you shipped on a device that you sent to a customer 5 years ago, but you're still supporting? Can you build it? Can you ship it? Ship that fix all the way to the user that is using your product. And also, will they upgrade? All of these things are difficult things. It doesn't really matter if you have a vulnerability in your product and you have a fix for that vulnerability. That is still just on your machine. It doesn't really matter if you can fix it if it doesn't actually reach your users, right? Yeah. So yeah, we need dependency management. We need them to be more advanced. We need integration with dependency scanners, and probably as a part of that, we need to standardize across dependency managers, because we need these. We are a relatively small developer community, and we still haven't standardized on a dependency management system. So while we're in this state, all of the security products that need to integrate with our dependencies are now needing to integrate with all of the different ways that we are doing stuff. And we are doing stuff in weird ways. So we need some way to standardize. And even if that means that we have like our local, this is our weirdness, we do it this way, then if at least you could standardize in this text file, here you have the list of our dependencies. Then the security tool could at least read that text file, match it against this database of known vulnerabilities, and tell you. Like, why are we having security vendors spend years on trying to scan file systems with files that we really should know what is there? Like, why are they doing hash matching of files when we should be able to just write in a file that, this is Openssl, this version? It's a waste of time. And it's a waste of time because we don't have order, right? Even though we feel like maybe we got this particular system or our project in order, we still need to integrate with other tools that could help us improve security. And as long as we are so different, and in the way that we do things are so different, it's going to be very difficult to make those tools. So I'm not saying that they should be the same, but at least I should be able to output the same file format. This is your transitive dependency tree in I don't care format. That means I'm warming up to XML again. I had a bad time like 10 years ago, but you know what? I had XML schemas back then. Then we went to JSON because everyone hates the angle brackets. And then JSON, you couldn't have comments in JSON. So then we got YAML. I don't care. I will parse it. Just if I could just have one format that I could parse and match somehow, or at least push to my security vendors and say, you need to look at this file and tell me if any of the versions of libraries in this file are vulnerable. That's all you have to do. You don't have to scan my file system, just this file. Just tell me. I know what's on my file system is in this file. Just tell me. Because right now, I don't have that. And I have that in most other programming languages. Okay, so we have some time for questions, but before that, I just wanted to show you a little bit on. So I've already shown you a little bit on how this works, but I basically here we go. Yeah. So this is the thing, and I'll show you the project. Okay, so the project is on GitHub. Maybe I should zoom. There we go. Yeah, so this is me trying to reformat so they're all the same. So if you go on GitHub, this is the project. Feel free to send me pull requests. I have never gotten so many pull requests in such a short time. I did not expect that. Like look at this. I have like a whole bunch, and I like how long is how do you tell how long this? It's like 3 weeks. This project has existed, and basically the structure I've showed you before. Under the unfinished tab, you have the conda, and then external project, and then Hunter. So if you have a way to integrate that is similar to this, like all I basically need is something that has what I would really like. First of all, I'd like to have a file outside of all of my stuff that is text or text equivalent, right? So a text file. It could be XML, JSON, I don't care, something parsable text file that only has my dependencies or stuff that is relevant to my dependencies. I don't want to write it in my CMake. That's just silly. I also want to be able to get all my dependencies through some kind of CMake magic, right? I don't really care what that magic is as long as I can put it into its own file and it doesn't mess with my CMake. So the optimal way for all of these is if I could have the exact same code and the exact same CMake, and the only difference was different files like this. And then you go like, Patricia, it's like you should marry your CMake, your dependency manager. And okay, I already married CMake. I'm not ready to commit. So this is still an open question. I'm not ready to say that, you know, for the rest of my life I'm going to be like a Conan person or a VC package person. I'm not there yet. I'm still, you know, on the fence. I want to be able to switch and to try, and especially because sometimes my dependency isn't available on all platforms. Like when I started this project like 3 weeks ago, then I pinged Diego from Conan on DM because I do that. So don't DM me because then I'll actually tell you stuff. And then I pinged Diego at Conan on DM, and I said, you know, SFML doesn't compile or isn't available for Linux, and so that breaks my entire thing. It's like I can't use Conan because it doesn't. I can only get it for Mac and Windows. But then he was like, you know, a week later he came back. He's like, yeah, we fixed it. So that's good. But it isn't always the case that the stuff that you need is available in your dependency manager. Like one of the things that I use for Turtle browser is I use Qt. Now, for some of you think, oh yeah, Qt is basically like an operating system. It is so big you have no idea. It even has a browser in there. Like this thing is massive, and compiling it is non-trivial, and adapting it to your use case is absolutely non-trivial. and so being able to just say to all of the users of the project that how to build it, you can download it from here. It will do all the magic for you. I've done the pre-configuration. You don't have to think about it. It still takes 7 hours to build, but don't worry about it. Okay, that is one of the things that I think is really sweet. As I am playing around with making a browser, and in that I use Qt Web Engine. with Conan. I use it to do my cute stuff. But there's no binary you can download. There's no binary for the browser. There's no library that you can download for like my specific version of Qt. So basically, if you want to run Turtle Browser, you have to build it from source. And that means building like Chromium. And so, so that means it's going to take, depending on your hardware, anything from 40 minutes to 7 hours. And I have had people submit bug reports. Like, I had the sweetest one. It was so, it warmed my heart. Somebody submitted a bug report that when they scrolled the web page, it was a little bit slow. And I'm like, honey, you just spent 7 hours building it. It's like, that is so nice. It's like you really put in the effort. So don't do that. Don't build my browser. It's like you don't want to go there. There will be binaries in the future, and it will still be a terrible browser. So, but I will still be having fun. So, and I think maybe that's why I'm I'm very excited about the whole dependency management thing, because I think it can make C++ better. Right now, we've like when I started at Opera, we had a separate build system for every platform. It was hooked up through some Perl stuff to some buttons so that you can press it so you can start a build. This wasn't true on Linux, but let's not go there. I made that Perl. It was the worst Perl you've ever seen, but the button worked. But we made our own bug tracking system. We made everything, right? Everything we made from scratch. Our own crash reporting system, our own crash analysis system, like anything you would need to make like a company that makes a browser, all of the tools. Where do you think Bugzilla came from? It's like everyone made their own thing. And I think and I feel like it's a part of our culture that we all have to make everything from scratch all the time. And I guess my what I'm trying to say in this talk is that if you want to make, all of you want to make your own way of doing dependency management, I can't stop you, but make standardized file format for your dependencies. So at least I can run a vulnerability scanner on that to tell you if these versions of these dependencies have a vulnerability. And I also think that it's about time that we actually start using tools. There are tools available. Yeah, they're not perfect. Make them better. Like all of these are like open source. Just go make the tools better instead of making your own tool all the time. It's like, and that's why I'm like a CMake person now. I have maintained like Linux build scripts and package scripts and all of those things. I've had sat next to someone who made an MSI installer from scratch and almost died, and yeah, and so we need to get away from the barrier of entry to this programming language. If we want people to program in C++, we also need to improve the developer experience of C++ and also improve how we find and maintain them, find vulnerabilities and maintain our applications, because it tends to be too hard. So if you want to see my silly so currently my Turtle browser is like all of my builds are failing, so just pretend you don't see that. And that's because I'm trying to upgrade currently to Qt 6. So this is a different type of a Conan file. So this is a Python file. It's kind of cool because it has lots of things you can do. One of the things that I do in here, which is also I mentioned earlier, is let's see, where are you? Down here. This is a problem, right? How do I know what the licenses of all of my dependencies are? I use this for Turtle Browser currently. It's not great. It basically says look for any files that exist in this tree that has something to do with the word license, and then just pretend that's a license file. So it's not super great, but it kind of works. So we need to solve this problem too, right? Everyone is solving this separately. Like I've talked to like 5 different companies, and they're all making tools to try to figure out if they're violating a GPL license. Do you know how much that costs? Like how many people you have to put in to do that? We need to solve this, right? Okay, so basically, I don't want to say everything is terrible because it isn't terrible. Like we have lots of tools now. Like this CMake stuff that I showed you, it's very short. It builds on all 3 platforms. The same thing, right? That's great. I can build the same application on 3 platforms and start up and get a window that has something. Like these are non-trivial problems that are solved by these things. And we've gotten very far. Okay. I think I'll stop there and open up for questions and or comments. Okay, first you clap. And if you want to go, you can go, and if you have questions, you can also ask questions. Or say, Patricia, you're wrong, and you can do that much easier. Yeah? Well, yeah. Okay. Okay, so you know what? We should add that to the repo. You can show me how. How VC package can give me as an application can give me what I need, and then I can update the repo, because now the repo is very nice if you want to see like pretty much a hello world on how to use this package manager. Then you can go and you can look at them. Which I haven't found before. You have to go to each one and you have to figure it out. And this is the same project doing the same thing with the different ones, so it makes it easier to compare. And we can definitely expand that to include licenses. Yeah, that would be very interesting. Anybody else? Yeah?
I have a question regarding the primary principle that you stated, that you want to run the dependency manager from the CMake file.
Mm-hmm.
Doesn't bother you that you have like 5 folders doing the same, just different stuff? For example, let's assume that you want to support 2 or 3 different ones, because we are open source project and we don't want to force our customers to use what we chose.
Yeah.
Right? So
unfortunately, currently, I can't use find package with a CPM and fetch content. And with VC package, I had to install the GL stuff. I had to use find package for the GL stuff on Linux. And so currently the CMakes are not the same, which sucks. But that's the state of it. I cannot have the same CMake files currently, which I'm not happy with, because that would be the optimal one. I could have the same. That's what I want. Yeah. I would want to have the same. If I can even like have like, these are my dependencies. Now I'm using this dependency manager, pick up the list of my dependencies and do the thing. So I would like to make this easier, but currently they're not the same. And that, like the C code is the same, but the CMake is not the same. And I'm not so happy about that.
Maybe probably Martin will agree that VC package probably doesn't force you to make the changes, right?
Well, yeah, well, VC, okay, Conan was the one that was closest to what I wanted, but VC package I had, let me see. So on VC package, I have to check, but I don't think I could use SFML : audio. And I had to do this to do find package for Openssl, and then for Linux, and I didn't have to do that with Conan. But VC package was the one that was closest to Conan, and then basically CPM and fetch content was basically the same. Like CPM is basically fetch content with like shorter syntax. Yeah. Any more questions? Yeah. Yeah.
One of the major problems, like in general, is that inside companies, the bonus incentives are on creating new stuff.
Yeah.
And it's not on making something someone else has done better.
Yeah, no, it's a very good point. That in many companies, the bonus incentives are on making new stuff and not improving the stuff that is already there. And that, I think, is the reason why Google has like 5 chat apps. Sorry. But it's true. And I think it's a problem we've had always, right? We're not very good at rewarding maintenance work, janitorial work, like people enabling other people to be productive. We're not very good at rewarding that. And I'm not saying necessarily only financially, but it's like just giving, like, you know what, I really appreciate that you do that. And like, my job is like so much easier now that you did the thing. Like sometimes it's not money we need, we just need somebody to see that we did a thing. But definitely money also matters. So if you see that somebody next to you just like making a really bad version of something that is already open source gets a massive bonus, then, you know, I can also make a bad version of an open source project. Yeah. Yes. I haven't tried that. It works? Okay, okay. Can you? Okay, it sounds rude, and I don't mean it rude. I don't mean to like. I'm honestly. I mean what I say now. Can you please give me a PR? It's like the typical like open source project is like PRs are welcome. It's like go away. But I'm serious. Like I'm honestly really interested in seeing the ways that this can improve, and especially I would like for having all of the CMake converge to be the same across the package managers. Yeah.
Also, one comment regarding that. You are doing an executable, so it works for you. Imagine doing a library that's
Oh, yeah.
also packaged, and you embed the package and dependency manager there.
Yeah.
And it's then distributed with PC package that uses internally Conan to do the rest.
Yeah. No, so he's saying that using making an application is one thing, making a library is another thing, and it is definitely. But the thing is, I'm usually the application developer. I'm not a library developer, so that's not my problem. So that's why I'm relying on Conan to fix it for me. Yeah.
That's for executables. Because for libraries, it will basically mix and match different package managers at once.
Yeah, and that's also something that you talked about in your talk yesterday with Meson, and I think it's a problem across all of these, is that everyone is building with different build systems and using different package managers for their own dependencies, and all of this kind of gets mixed together, and that's sort of why I like VC package and Conan. Because having someone who actually sat down and thought about how things work together, that is not me. I really appreciate. Yeah. So it's a non-trivial problem to try to make order in this chaos that we have. But I think it matters. I think it's important, and I think it will help on security if we can actually get to that point. You have a question. I can see it. No, it's you. You, yes. Yes.
Basically, extend the fact that you don't have to change the C standard, the VC package and Conan means that either they fetch around the auto pointer,
Yeah.
for example, by adding the define to not deprecated,
Yeah.
or you have massive problem in your application because if you compile different parts of your application with different compiled flags, that's basically saying ODR.
Yeah. No, I'm counting on VC package and Conan to do that. They're doing the right thing somewhere. No.
I wanted to mention this after the talk. As you already stated this one, actually this is an ABI problem here, and API potentially too.
Yeah.
Version standard influences both API and ABI.
Yeah. No, No, the thing is, yeah. Okay. So let's see if I can restate the question or the comment. The fact that SFML uses auto pointer becomes my problem because now if I try to compile parts of the code with C++17 and parts of the code with C++14, then I'm going to have like ABI problems, right? That was more an API potentially too. And that's true. I'm kind of, because these are curated packages, I'm kind of hoping that Conan and VC package solve that for me. At least they didn't give me an error, which on the other hand, you could say that it's like, that's probably worse. Like if they didn't somehow fix this for me by patching or something else, then they just silently failed for me here.
They just use the default version, use the compiler, which is 14, for the compiler you chose. And then you are linking to those.
Okay, but that means I have a problem now. Yes. Yeah, I don't like that. I don't like that story. So either it should fail or it should do the right thing.
It will if you write the version in the kernel file, in the profile, sorry.
Yeah.
Also, if your dependency is still today using auto pointer in the latest release, maybe that's not a good dependency to have.
Yeah, no, you should definitely tell that to the SFML people. Yeah, and or maybe submit a pull request to them to upgrade, because auto pointer is like really old. Like why? Like really old. Like.
About auto pointer, for example, variant.
Yeah.
14 uses some Openssl variant. 17 uses stud variant. API issues.
Yeah, no. But the thing is, auto pointer was old in 14, like old in 14 too. Like auto pointer was old in C++11. Like that's 10 years ago, and it was old then. So yeah. It was deprecated in 11. So 10 years later, here I am. Any other questions or comments?
Yeah. So at the beginning, you made fun of NPM because C++ developer like to make fun of NPM. Like doesn't.
Oh, I love NPM.
The fact is that it works.
Oh yeah.
And Cargo works.
Yes.
And so, what's your opinion of why C++ like try to be special, and why do we have like 10 different dependency management? Because like, what's the value of having Conan and VC package instead of just saying, okay, use that tool. It's not perfect, but it works.
So what is the reason why we always have to be so special?
Yeah.
I think it's a culture. I think it's a culture thing in the C++ community, because we are using C++ because we want to control everything. We want to know how everything works because it matters, right? Because we're using C++ on platforms where it matters how things work, and that is good in certain aspects because we need it to make our products. But we tend to like just explode that thinking on lots of stuff that we don't need to apply it to. And so we're like, I don't like magic things. I want to know how it works. I want to be able to control every little bit of everything. I think it is a part of our culture. And you could tell all C++ developers that you should change, but I don't think that works. So then we have to work inside of that mentality, and I think if you accept that kind of mentality, I think you can, and I think that's what we've seen with CMake, with Conan, with VC package. Oh, no, sorry, I got something in my throat. Any more questions? Okay, then we're done.